So in this video, we are continuing what we started with the first. So if you haven't seen the first video on comparative advantage with input problems, you should watch that one first. I'm just going to jump straight from our learning target here, being able to solve absolute comparative advantage problems, go right to, again, the output situation now, because now when we were looking at solving input problems for comparative advantage, our rule for determining opportunity cost was we would take the other number, the input number, into the other in order to find it. Now if it's an output problem, the rule changes. It's going to be output over. So again, remember that an output problem is one where the quantity of output produced is given from a quantity of input, like the number of wagons we can produce in a day, the number of bushels of apples we can grow on an acre of land. The amount of the input is fixed at 1 day of labor time or 1 acre of land, and the numbers in the question or problem are the quantities of the output that we get from it. So here is another example. This time we've, again, dealing with robots and pizzas, but notice it says the number produced per day. So the per day part is the amount of the fixed input, the amount of labor time that we're given, and the numbers in the question represent how many robots or how many pizzas we can make with that amount of input. Again, we put the people or the countries or whatever as the row, and then the goods or services as the columns. For Barney, in 1 day, he can make 4 robots or 24 pizzas. Lala, 2 robots or 18 pizzas. So for absolute advantage, this is the one and only time where bigger is better, right? Barney is able to make more robots than Lala, 4 to 2 in a day. So Barney has absolute advantage for making robots and also for making pizzas, because 24 pizzas is bigger than 18 pizzas. If it's absolute advantage for an input problem, you want the lowest number. That's the one that has absolute advantage because they're using less of the input to make that good. And whenever you do comparative advantage, doesn't matter. Input, output problem, lower is always better, just like limbo. How low can you go? So down at the bottom now, we're going to apply output over as our rule in order to get the opportunity cost. So when I want to know what Barney gives up as opportunity cost of making a robot, I take pizzas and I put it over. So 24 over the 4, 24 divided by 4 is 6. And then I'm just going to do the reciprocal, the opposite. When I want to know the opportunity cost for Barney to make pizzas, I put the 4 over the 24, which reduces down to 1/6. For Lala, it's 18 over 2. So every time Lala makes a robot, Lala gives up 9 pizzas. And when I put the 2 over the 18, I see that every time that Lala makes a pizza, you give up a sacrifice of 1/9 of a robot. So now I say, who has the lower opportunity cost? Who gives up less to make robots? Well, Barney only gives up 6 pizzas to make a robot. Lala gives up 9. Since 6 is lower, Barney has comparative advantage to make or build robots. Barney should specialize according to that comparative advantage and make the robots. When it comes to pizzas, 1/9 is smaller or less than 1/6. So that means that Lala has the comparative advantage there and should specialize according to that comparative advantage. So Lala should specialize in pizzas. Now, another common way these problems might be given to you is with our old friends, the production possibility curves. You should celebrate if that's the case, because the fact that it's a production possibilities curve automatically means that you know that it has to be an output problem. So the first thing I do when I get one of these problems is I set it up just like the format that we're used to doing. So I'm going to put alpha and omega, the 2 countries here, as the rows, and the 2 products, cattle and sheep, as the columns. since these are production possibilities, it's, what is the maximum number of cattle or sheep that Alpha and Omega can produce? So given their resources, the maximum amount of output for Alpha is 500 cattle, or if they use all of their resources to make nothing but sheep, it would be 500 sheep. For Omega, it's 250 is the maximum output of cattle, or 125 the maximum output of sheep. Now our rule is output over in order to calculate our comparative advantage. In terms of absolute advantage, it's an output problem, so bigger is better. Alpha can produce more cattle, 500 to Omega's 250, and more sheep, 500 to 125 sheep. So Alpha has absolute advantage in both things, but that doesn't mean that they shouldn't specialize according to a comparative advantage. So if I take 500 and put it over 500, then my opportunity cost is going to be, 500 over 500 is 1, and then output over the opportunity cost of the sheep again reduces down to 1. For Omega, if I want to know the opportunity cost of the cattle, I take 125 and put it over the 250, which is 1/2. If I want to know the opportunity cost of the sheep, I take the 250 and put it over the 125, which is 2. So in other words, every time Alpha wants to raise cattle, it has to sacrifice 1 sheep. Every time it wants to raise a sheep, it has to sacrifice 1 cattle. In Omega, every time they raise cattle, they give up 1/2 a sheep, and every time they raise sheep, they give up 2 cattle. So who has comparative advantage? We always look for the low number, right? So when it comes to cattle, what's smaller, 1/2 or 1? 1/2. So we would say that Omega has comparative advantage. They should specialize in cattle. And when it comes to sheep, Alpha gives up 1 to Omega gives up 2. 1 is less than 2, so Alpha has comparative advantage and should specialize in raising sheep. One last thing I'm going to throw at you because it hasn't come up yet, but many times in these comparative advantage problems, they get to questions about terms of trade. So people will voluntarily trade when it's in their interest. So it makes sense that it has to be advantageous to both sides in order for the trade to happen. If the terms are not between the two countries' own opportunity costs, they will not find it advantageous. So if let's say we were told that the terms of trade are 1 sheep are equal to 1.5 cattle, because 1.5 is between Alpha and Omega's opportunity cost of 1 and 2, 1.5 is right between, it means both sides would benefit. From Alpha's point of view, they're specializing in sheep, and so instead of trading, if they were to make cattle or grow cattle themselves, they would have to give up 1 sheep to get 1 cattle. Under the terms of trade, they can trade 1 sheep and get 1.5. So that is an advantage to them. Omega is specializing in cattle. Right now, they have to give up 2 cattle in order to get a sheep. Under the terms of trade, they would only have to give up 1.5. So again, that is a situation showing how the terms of trade are beneficial when the terms fall between the two countries' domestic opportunity cost.